Hi everyone. Today let's talk about chapter 7. Chapter 7 is about integration techniques. So we're going to learn more integration techniques to help us to solve more kinds of integrals. But however, remember, we are not able to solve most of the integrals. The integrals of most of the functions. Okay? So the ideas. Integration by parts is an integration technique that allows you to integrate the products of two functions under certain circumstances. Integration by parts is really the product rule in reverse. However, it does not work in every case when where the integrand is a product of functions. So do you remember I told you before there's no product rule and quotient rule for integrals? However, there is some thing similar to product rule. It's called integration by parts, but it does not work for all the products of two functions. It only works for the products of some special types of functions. Okay, so big skills. You should be able to identify appropriate choice for u and v, apply those choices to the integration by parts formula, and know if and when you've made that choice for u and v. Okay, so what is the formula for integration by parts? So suppose u and v are differentiable functions, then integral of u dv equals uv minus integral of v du. Okay, so you remember the last time we talked about u substitution and we only have the u. But today we have two parameters, u and v. Okay, so I want to recall you. Do you remember the product rule for derivatives? So is the derivative of uv equals u dv, the derivative of v plus the derivative of u times v, right? This is the product rule. Okay, now I'm gonna integrate both sides with respect to x. So integral of, okay, let me copy it down. U dv dx plus du. Okay, I'm gonna put the v in front. Okay, so now what happened? Well, this kind of cancel. Integral of 1 with respect to uv is just uv. And then this guy cancels, so we have integral of u dv plus integral of v du. Now let me solve for integral of u dv. So we move this guy to the left, then we get integral of u dv equals uv minus integral of v du. So we derive the integration by parts formula from the product rule of derivatives. So now I hope everybody read this formula with me. So you're gonna need to memorize the formula. It's like memorize your name, okay? So everybody read with me. Integral of u dv equals uv minus integral of v du. Again, integral of u dv equals uv minus integral of v du. Okay, now everybody close your eyes. Read it with me. Integral of u dv equals uv minus integral of v du. Okay, so have you memorized it? If not, please give me your phone number. I'm gonna call you at midnight and wake you up. Hey, hi, wake up. What's the formula for integration by parts? Okay. So next, let's continue. Let's look at this formula. Okay, so what do we do to u? So you see the u, we are trying to differentiate the u. Okay, how about the dv? Well, the dv want to get the v, so we want to integrate the dv. So we let u be something we can differentiate and make the problem easier. And for the dv, we want to try to integrate it, and the problem is not harder. Okay, now let's look at the next examples. So example 1, part A, integral of ln of x. So you always find your u, and then whatever left is going to be dv. Okay, so remember u is something we can differentiate and make the problem easier. So ln of x, can you differentiate ln of x? Yes, derivative of ln of x is 1 over x, right? So this suggests that we should let u be ln of x. So this is u, and then whatever left is gonna be dv. So you pick your u first, and then whatever left is gonna be dv. Okay, then what's du? Well, 1 over x dx. Don't forget your baby dx. Many students forget that. Think about it. So du and dx, they're like differentials. They're like two kids playing seesaw. You cannot have a kid left. So if he left, then one kid cannot play a seesaw. So that's why you have to have the du and dx on each side of the equation. Okay, and then what's the integral of v? Integral of, if we integrate both sides, integral 1 with respect to v is just v, integral 1 with respect to x is just x. And this is the only place you don't need to write plus c. Okay, remember whenever we integrate, I always ask you, plus c, don't forget your cell phone, c for cell phone, right? And here, this is the only place you don't need to write plus c. It turns out you write plus c or you don't write plus c, you get the same thing. Okay, so that's why you don't need to write plus c here. Then by our integration formula, our integral becomes u is ln of x, v is x, minus integral of v, which is x, du is 1 over x dx. Now x cancel, so we have it's better to move the x in front, because then we won't get confused whether the x is inside the ln or outside the ln. And then the second term, it becomes integral 1 dx. So this is x, ln of x, minus integral of 1 is x, and then plus c. So here, remember at the end, after you finish integrating, you need to include plus c. So far, so good, everybody? Alright, let's continue. Okay. So remember, we let u be something we can differentiate. Like the previous examples, you can differentiate ln of x, but can you integrate ln of x? No, because that is what we are looking for. We want to find the integral of ln of x. So of course, we don't know how to integrate it. So that's why we let u be ln of x. We want to differentiate. Okay, next problem. Let me use this color. Okay, so what do we want to let u to be? Okay, see, there are two functions. Shall we let u be x? Think about it. If we let u be x, the derivative of x is 1. Oh, it's easier. But if we let u be e to the 3x, the derivative is 3 e to the 3x. So the exponential term is still there. So we're not making the problem easier. So that's why in this case, we should let u be x. And whatever left is gonna be dv. Okay? So do you remember u substitution before? We said you cannot let u be x because you just get the same thing. Yeah, that is for u substitution. But here, integration by parts, you can actually let u be x because it has two terms, u and dv, okay? So it's different from the u substitution. And then du is 1 dx. And then we want to integrate both sides. Integral of e to the 3x is e to the 3x, but we integrating it, so we divided by 3. So far, so good, everybody? And then we use the integration by parts formula, uv, so x times 1/3 e to the 3x minus integral of v du is dx. All right. Oops. What happened? Let me see. Okay. So that's why it's x over 3 e to the 3x minus, well, okay, what's integral of e to the 3x? That's e to the 3x divided by 3. So finally, x e to the 3x over 3 minus e to the 3x over 9 plus c. So this is the answer. So far, so good, everybody? All right, let's continue. So this problem, you can see what do we let u to be? So there are two functions, x and sine 7x. If we let u be x, du will be just 1 dx, right? But if we let u be sine 7x, the derivative of sine is cosine, and chain rule is 7 cosine 7x. Ooh, it's not making the problem easier. So we should let u be x. Then whatever left is gonna be dv. So far, so good. And then du is 1 dx. And we want to integrate. Integral of sine is negative cosine, because derivative of cosine is minus sine. And you also need to divide it by 7. So far, so good, everybody? Maybe it's better to write it like this. Okay, so our integral becomes uv, so minus x cosine 7x over 7. Okay, that's uv minus integral of v. V is negative cosine 7x over 7. du, well, du is just dx. All right, this is minus x cosine 7x over 7. Minus minus become plus, and 1 over 7 we can put in front. Okay, what is the integral of cosine? Well, the derivative of sine is cosine, right? So it's positive sine 7x, but we also need to divide it by an extra 7 in front, okay? And so our final answer, minus x cosine 7x over 7 plus sine 7x over 49 plus c. So far, so good, everybody? So you can see part B and part C, if we have polynomial and exponential function, or a product of polynomial and sine and cosine, we usually let u be the polynomial, because when you take the derivative of the polynomial, your degree decrease by 1. So we let dv be the exponential function or sine and cosine, because when you're taking the integral, it's not making the problem very harder, because the integral of exponential function is still exponential function, and integral of sine and cosine, they just interchange. Okay, let's continue. All right, so part D is x squared. So part D is quite similar to part B, you see, but instead of x, now we have x squared. So it means we might need to use integration by part twice. Okay, so first we let u be the polynomial, then dv is gonna be whatever left. That is e to the 3x dx. And then du is 2x dx. Alright, the integral of that one is, okay, what is that? It's 1/3 e to the 3x. So far, so good, everybody? Okay, so this guy is uv, so x squared times e to the 3x over 3, uv minus integral of v du is 2x dx. Okay, let's see, what is this? So we can factor out 2 over 3, and then we have x e to the 2x dx. Ooh, you see this guy, we're gonna use integration by parts again, but we already did that. sorry, this is 3. This is 3. Okay, but we already did that in part B, so we can write it down here. So x squared e to the 3x, 3 minus 2 over 3. Okay, let's see what is the answer from part B. Okay, so this guy, right? X e to the 3x over 3 minus e to the 3x over 9. X e to the 3x over 3 minus e to the 3x over 9. Alright, so let's see, what do we get? Okay, distribute. So it's 2x e to the 3x over 9 minus become plus. 2 e to the 3x over 27, and 2/3 times c is still a constant, so we name it to a new constant d. So far so good, everybody? Okay, so sometimes a problem you might need to use integration by parts twice or 3 times. Okay, now let's look at this one. Well, we have exponential function times sine. Okay, so which one we should let u to be? If we let u to be exponential function, the derivative is still exponential function. If we let u be sine, the derivative is cosine, still a trig functions, right? So actually in this problem, you can let u be either one. Either one will work. Okay, so how about let's let u be e to the 2x. Okay, and then dv is sine 5x dx. Then du is 2 e to the 2x dx. The integral of sine is minus cosine. So far so good? Alright, so and we use the integration by parts formula, and we get uv minus integral of v du is 2 e to the 2x dx. Alright, let's simplify it. So minus e to the 2x cosine 5x over 5. Minus become plus. And we get 2 over 5. And then we have e to the 2x cosine 5x dx. So far so good? You can see we start with e to the 2x sine 5x. And we do integration by parts once. Then we get e to the 2x cosine 5x. So what do we do? Okay, don't worry. Do integration by parts one more time. Then you will get e to the 2x sine 5x back. You might ask, it's not gonna be helpful if we get it back. Don't worry, I will show you the trick later on. Okay, so let's do integration by parts again. So let's use green color. Okay, so now let me just solve this integral. Okay, so u is now still let it be e to the 2x, but dv is cosine 5x dx. Well, du is then 2 e to the 2x dx. Okay, integral of cosine is sine 5x over 5. So far, so good, everybody. And let's call this guy I, because I don't want to compute the whole integral. So the integral I is uv minus integral of v du. So it's e to the 2x sine 5x over 5 minus 2 over 5 integral of e to the 2x sine 5x dx. Plus, and okay, now let's plug it back. So watch carefully. We start with integral e to the 2x sine 5x dx. Okay, let me see whether I can create more space here. Okay, so create more space. Okay, so we have this, and that equals minus e to the 2x cosine 5x over 5 plus 2/5 of this guy, right? 2/5 times this guy. 2/5 times the first guy is 2e to the 2x sine 5x over 25. Right? 2/5 times the next guy is 4 over 25. And integral e to the 2x sine 5x dx. So far, so good, everybody. Okay, right now, we can solve for this. How do we solve for this? I can show you. Okay, let me do an analogy here. So if you have y equals minus 5 plus 2 minus 4y, how do you solve for y? Well, you both sides add 4y, right? You move this guy here, then you have 5y equals minus 5 plus 2 minus 3. And then your y is negative 3 over 5, right? Here, the same thing. The rectangular box is like the y, right? Okay, so we move this guy to the left. Okay, then you have 1 plus 4 over 25. That is 29 over 25 of the integral of e to the 2x sine 5x dx. Okay, so why do we get this? Because this is 1 plus 4 over 25. Alright, and what's left? Minus e to the 2x cosine 5x over 5 plus 2 e to the 2x sine 5x over 25. See, now we're ready to solve for the integral e to the 2x sine 5x dx, because that is the right hand side times 25 divided by 29. Well, when we times 25, the 5 and 25 cancel one copy of 5. So we get 5 over 29 e to the 2x cosine 5x. And the second term, it becomes 25 cancel. So 2 over 29 e to the 2x sine 5x. And at the end, you can plus c here. So far, so good, everybody. And so this is our final answer. Yeah, so when you see a product of exponential function and sine, it could be also exponential function times cosine. You do this trick. You do integration by parts, then you get the exponential term times sine and cosine, the other one. And then you do it one more time, you get it back. And then once you get it back, you can move it to the left-hand side and solve for it. And then you can solve the integral. So far, so good. Let me continue to box it. So you can see this is the box Y. Alright, so far, so good. Okay, let's continue. Okay, so let's look at this example. What do we want to let u to be? First of all, can you integrate sine? No, that's what we're looking for, right? So it means we have to let it be u, right? So u is sine of 2x, and dv is whatever left, just the x. Well, du, what is the derivative of sine of 2x? Well, that is, what is that? 1 over square root of 1 minus 2u. This is actually chain rule with the u is 2x. Okay, so it's 1 over square root of 1 minus u squared times u prime. So 2x prime, which is 2 over square root of 1 minus 4x squared. So far, so good, everybody. All right. And what is v, well, v is just integral of 1 with respect to x is x. Okay, so my integral is uv, so x at sine of 2x minus integral of v du. Oops! See what happened? I forgot my baby. So dx is another baby. You have your parentheses is the first baby. Dx is the other baby. So don't forget your baby. Alright, so, okay. So integral of v du. So, that means we can have like 2x and then 1 minus 4x squared dx. So far, so good, everybody? Okay, how do we integrate this guy? Use substitution. Abuse of notation. So many u. You see chain rule, there's a u. Integration by parts, there's a u. And here, this is the u substitution. There is another u. So, let me write it down. Okay, so here the u is chain rule. Here the u is integration by parts. Here the u is the u substitution. Oh, so this is really a good example. So it can gather all those confusing things together. So now we can make it. We can see the difference between them and compare them. Okay, so I don't want to call it u again. So let me call it w. So you let w be the things inside the square root, right? So 1 minus 4x squared. Then dw is minus 8x dx. But on the top, we only have 2x dx. Well, how do you get 2? Well, you divide it by both sides. You divide both sides by negative 4. So negative 1 over 4 dw. Okay, so let's calculate this box first. Well, then this box equals negative 1 over 4 integral of w to the negative 1/2 dw. Is that okay, everybody? So 2x dx is minus 1/4 dw. And the square root is in the denominator, so it's w to the negative 1/2. What's the integral of that? We add 1 to the exponent, it becomes 1/2. Divided by 1/2 is the same as multiplied by 2. So this is minus 1/2. W, what is w? This is the same as square root of 1 minus 4x squared. Alright, now, so what is the whole thing? Well, the whole thing is x at sine of 2x minus become plus 1/2 square root 1 minus 4x squared and plus c. So far, so good, everybody? So this is our answer for part F. Alright, let's continue. Oh, okay, so... Okay. Alright, so next, I want to make the problem more interesting. So let me change a little bit. Okay, let me change this guy to the power of... Okay, how about let's change to the power of 11 over 3. Okay. Alright, let's make it more interesting. So, right now, what do? Okay, even though we let u be the power function, the degree will decrease by 1. It looks like easier. But the problem is, you see in the natural log, we are only able to differentiate because we know the derivative is 1 over x. We're not able to integrate. So that's why this guy, even though you differentiate, make it easier, but this one you have to differentiate, you cannot integrate. So that's why this guy dominates. So u must be ln of x, right? Then dv is whatever left, x to the 11 over 3 dx. Okay, du is 1 over x dx. V is then Well, we add 1 to the exponents. That's 14 over 3 divided by 14 times 3. So far, so good, everybody. So our integral becomes uv. So ln of x, v is, let's put the 3 and 14 in front. And then we have x to the 14 over 3. So far, so good. Minus integral of v. Oops. Sorry. Write a wrong number. Over 3. du is 1 over x dx. Alright, so what do we get now? Okay, can you see this x and that x can cancel? So it's like 14 over 3 minus 1 is 11 over 3. So this is 3 over 14. We can do x to the 14 over 3 ln of x minus, we can factor out after 14, and this guy is x to the 11 over 3 dx. We can go ahead and integrate it. Okay, so what is that? X to the 14 over 3, right? We add 1 to it. So divided by 14 over 3. So the 3 flip on top. So this is actually 3 squared is 9. What's 14 squared? Okay, so let's see. We can use our calculator because 14 is quite a big number. We can use it as calculator. That's 196. Okay, so this is our answer. So far, so good, everybody. Okay, so right now, I want to summarize with you. What are the cases we have seen? Okay, so the case we see is the first type is the product of polynomials and exponential functions, or the product of polynomials and sine and cosine. So in this case, we always let u be the polynomial, okay? And the rest is dv. The second type we see polynomials or power functions times natural log, x sine, x cosine, r, tangent. So I will summarize the second type as, well, polynomial times inverse function. Because, you know, ln of natural log is the inverse function of exponential function, and the inverse trig functions, they are inverse function of the trig functions, right? So second type, if we have polynomial times an inverse function, you always let u be the inverse function. So we let u be the inverse function, because we're only able to differentiate those inverse functions, like natural log, x sine, x cosine, all of those inverse functions. We're only able to differentiate them. So let it be u, don't let it be dv, okay? And the third type, we have exponential function times sine and cosine. Well, we just, you can let u be either one. Both works. So when you do integration by parts, you get suppose you have e to the exponential function times sine, you do integration by parts, then you get exponential function times cosine. You do it one more time, then you get it back. So you just solve for it. Move that integral to the left and solve for it, like our example. So far, so good. So we are only able to differentiate the products of functions in like these three types. So in general, any product we're not able to integrate. Okay, so that's why we're still very limited. We can only use integration by parts for these certain types of products. Okay, so next, definite integral. So when we have definite integral, it's okay, just find the indefinite integral and then plug in the bounds. Okay, use the fundamental theorem of calculus. Find the antiderivative and then plug in the bounds. So let's look at example 2. So we have the inverse function at cosine. Well, then just let u be the at cosine. And then dv is whatever left, just dx. Okay, what is the derivative of arc cosine? It's very similar to the arc sine, but you just have a minus in front of it. Integral of 1 with respect to x is just x. So our definite integral. So first we compute the indefinite integral. So the indefinite integral equals uv. So x arc cosine x. By the way, arc cosine x is the same as this. Same thing. And so uv minus integral of v. Oh, I forgot my baby. Be careful. Integral of v du. So the minus, flip it to positive with 1 minus x squared dx. So far, so good, everybody. Okay, then here, oh, you see there is another u substitution. Do you see the bottom here, right? This guy, the derivative is 2x dx. So if we let this w, then dw is 2x dx. Well, here I'm gonna do a quick way of u substitution. I want to match the dw, so I want to match a 2 here, but we cannot just multiply by 2, we also need to divide by 2. So then now this is x arc cosine of x plus 1/2. Now we we have dw on top and square root of w in the bottom. So that's w to the minus 1/2. And how do we integrate? Is w to the 1/2. Our w is 1 minus x squared to the 1/2 multiplied by 2. Okay. So if you're familiar with the u substitution, you don't need to write these. Okay? You can have this in your mind. But if you're not familiar with that, it's okay. Write down the details. Alright, so this is our answer plus C. So far, so good, everybody? Oh, I realized I make a mistake. And this is also a very common mistake. Do you know what mistake I made? See? I forgot the negative. So this should be negative, then this guy should be negative, this guy should be negative and negative. Yes, be careful, everybody. All right. And so this is the indefinite integral. We still need to plug in. Okay, let's continue and plug in. So 0 to 1/2 arc cosine x dx. So that is x arc cosine x minus square root 1 minus x squared. Evaluate from 0 to 1/2. That means we plug in 1/2 first. Minus, okay, 1 minus 1/2 squared is 1/4. And then we plug in 0. Oh, 0, this is 0. And, 1 minus 0 is 1. So be careful, there is a parentheses. What is arc cosine of 1/2? Okay, what's the picture of cosine? So cosine looks like this, right? Arc cosine of 1/2 is talking about when you look at your cosine, the x values of your arc cosine correspond to the y value of your sine. So we know this is 1. If the y is 1/2, what is this x values? Well, we know this is pi over 2, then this is actually pi over 4. Sorry, pi over 3. Okay, so this is pi over 3 minus, this is square root of 3/4. So square root of 4 is 2. And then add 1. So we have pi over 6 minus root 3 over 2 plus 1. And this is our answer. So far, so good, everybody? Alright, let's continue. Okay, so this problem, what do we want to let u to be? Remember polynomial times sine and cosine, so you just let u be the polynomial, and then whatever left is gonna be the dv. So du is dx, v is integral of that, so 1/2 sine 2x. Okay, so, and what's next? So we have the indefinite integral, that's uv minus integral of v du, which is just dx. So we get, copy it down. What's the integral of sine? Well, it must be cosine, but plus or minus. You think about the derivative of cosine is minus sine. So this is minus cosine, but minus we make it positive. And you also need to divide it by 2. And don't forget your cell phone. So this is 1/2 x sine 2x plus 1/4 cosine 2x plus c. Finally, our definite integral equals that function evaluates from 0 to pi over 2. So that means we plug in pi over 2 first. So we get pi over 2 times 2, 4. Sine of 2 times pi over 2, that's pi. And then plus 1/4 cosine of pi over 2, which is also pi, minus, when we plug in 0, oh, the first thing is 0. The second thing, cosine 0 is 1. All right, what's sine pi? You see, sine pi is 0. What's cosine pi? Is minus 1. Oh, so it's minus 1/4. And here we have another minus 1/4. So the answer is minus half. So far, so good, everybody. All right. And so this is session 7.1. We talk about integration by parts. It helps us to solve the integral of some types of products. Okay, the type of products includes polynomials times exponential function, polynomials times sine cosine, polynomials times inverse functions I mean natural log, the inverse trig functions, or products of exponential function and sine cosine. But all the other products, all the other products so remember, we're not able to solve the integrals of most kinds of products, so we're still very limited even though we learn more and more integration techniques. Okay, so that's the difficult parts about finding the integrals. We not always get a nice formula like the derivative. So that's why through calculus 2 we will learn some integration techniques this chapter, but we're not able to integrate most kinds of functions still. So if in the future, if you're gonna take numerical methods, actually we can use numerical integrations to approximate any definite integral as close as we want. So a very useful technique. All right, have a nice day. Bye.